Hello and welcome you all for today's lecture on the third topic, that is steam and steam boilers from the subject thermal engineering. So we have already started with this chapter and we have seen most of the important points from the steam part, that is how the formation or generation of steam takes place. Before that we have also studied what is the difference or what is the meaning of sensible heat and latent heat. Then after studying the formation of steam from ice, we have studied several properties of steam such as enthalpy, entropy. Then again we have seen what are the various conditions of steam, like the meaning of wet steam or dry saturated steam and superheated steam, along with the concept of degree of superheat. Then we have also studied the diagram, that is temperature versus entropy diagram. So all these points are very important from exam point of view, and in today's lecture we will continue with the steam part, that is we will be studying what is the Molier diagram and how to use the steam table. So I hope that after going through today's lecture you will be able to understand what is this Molier diagram and how to use the steam table for solving the numericals. Now we will start with the new point, that is Enthalpy-Entropy diagram, or we call it as Molier diagram. So up till now we have seen what is TS diagram, that is temperature versus entropy. Then again we have seen TH diagram for the formation or generation of steam. So along with all these diagrams, it is also important to study the relation between enthalpy and entropy. So this diagram, as we can see on the right hand side, the entropy is plotted on x-axis, whereas we are having enthalpy on y-axis. This chart is very important in case of engineering problems, because many times it is necessary to determine the amount of heat required which is to be supplied or removed from the system whenever there is a change in entropy during the process. So if we are going to prefer the theoretical formulas and all for the calculation purpose regarding the amount of heat which is supplied or to be removed, then it is generally time consuming, and for this purpose Dr. Molier prepared this HS diagram, and thus this enthalpy versus entropy diagram is called as Molier diagram. If we look at the diagram, then again in this diagram we can see one bell-shaped curve which is represented by the curve A, B, C and D, and we can divide this curve into two portions. So the first portion, that is if we consider line AB, then it is called as saturated liquid line, whereas the remaining part of the curve, that is line B, C and D, it represents the dry and saturated vapor line. So it is important to note that in this diagram, that is enthalpy versus entropy, point B indicates the critical point. So similar type of diagram earlier we have seen in case of TS diagram, where C was the critical point, but in case of enthalpy versus entropy diagram, you should note that point B will be critical point. Again the portion above the saturation line is the superheated region, and the portion below the saturation line we call it as wet region, or it is also called as two-phase region, since it is a combination of liquid plus vapor region, so we also call it as two-phase region. Now if we consider all the different lines which are present in this diagram, then if I try to explain all these lines in the same diagram, then it will be difficult to identify or to remember what is the representation of each line. So I have separated all these lines so that we can study each and every line one by one. So let's see what all those lines are present in this Molier diagram one by one in further slides. So the first line that is present in this Molier diagram, we call it as dryness fraction line. So on the left hand side you can see that just below the saturation line there are several lines or several curves where we can see the different values for x. So x is equal to 0.85 or x is equal to 0.90, then again 0.95. These lines are called as dryness fraction lines. So you can see on the right hand side also how these dryness fraction lines are represented by dotted lines. The value of dryness fraction, it varies from 0 to 1. So you can see that as we move closer to the saturation line, the value of dryness fraction goes on increasing. So if we consider the saturation line itself, then for this line the value of dryness fraction, that is x, it will be equal to 1. The dryness fraction lines are drawn only below the saturation line and in the wet region. So these lines represent the condition of wet steam between the various values of enthalpy and entropy. So this was about the dryness fraction line. Now we will see the second lines, that is the constant volume lines on the Molier diagram. So again we are having a diagram. We can see in the first diagram how the values of constant volume lines are represented. These lines are drawn in both, that is the wet region as well as in the superheated region. And these lines are somewhat straight in wet region, and it slightly gets curved when as we go in upward direction above the saturation line in superheated region. We can also see these constant volume lines on the right hand side, that is the actual Molier diagram, where this line is again represented by dotted line, and we can see there that is V equal to C, which is nothing but it represents a constant volume. Now the next line, we call it as the constant pressure lines on the Molier diagram. So in this case these lines are again drawn in both wet region as well as in the superheated region, and again these lines are straight in wet region and slightly curved upwards above the saturation line, that is in superheated region. So again you can also see these lines on the actual Molier diagram. So these are represented by a dark line where we can see the pressure is given, that is P is equal to C. Now after constant pressure lines, the next lines are the isothermal lines on Molier diagram. So the isothermal lines, these are only drawn above the saturation curve. So you should note down this, because we have seen that in case of constant volume lines and constant pressure lines, those lines are present both in wet region as well as in superheated region. But the isothermal lines, these are only available on or above the saturation curve, and these lines represent the condition of superheated steam between various values of enthalpy and entropy. After the isothermal lines, again we are having the isentropic lines on the Molier diagram. So isentropic, we know that it is nothing but constant entropy. So we can represent these lines exactly parallel to the y-axis. So we can see in this case the line 1 to 2, it represents the isentropic line. So if we consider the right hand side, that is the actual Molier diagram, and there is no actually isentropic line drawn in this case. But if we are plotting any value between the two pressure lines, just as shown in this left hand side diagram, So we are just taking one example where we are considering a steam at 10 bar and say 300 degrees Celsius temperature. So if such kind of steam is expanded to pressure say 0.5 bar, so this process of expansion is shown by this process, that is by line 1 to 2, and by plotting these values we can determine the values of enthalpy at point 1 as well as at point 2. So in this way, if we are just knowing the pressure and temperature values, then easily we can determine the values of enthalpy by using this Molier diagram. Now just like we have seen the line parallel to y-axis, we call it as isentropic process, represented by this line called as isentropic line. Similarly, if we plot another line which is parallel to x-axis, then we will see what it is called in the next slide. So it is called as throttling lines. During throttling process, there will be no change in enthalpy, and thus the throttling process is shown by this horizontal line on the Mollier chart. Again, we are not represented this line on the actual Mollier diagram, but in several numericals or in several engineering problems, we are required to determine the value of entropy. So if we are having the values of pressure and the dryness fraction, so if we consider again the left hand side diagram, we can consider that a steam, it is expanded, that is it was initially having pressure say 14 bar, and if it is expanded to pressure say 1 bar with dryness fraction, that is say if we consider that the steam is 80% dry, so this 80% dryness fraction, it means that x will be equal to 0.8. so if we are having such kind of data, that is the pressure values and the dryness fraction at initial, then we can easily find out what might be the dryness fraction of the steam at the final stage or at the end of the process. So this was all about on the Molier diagram or the enthalpy versus entropy diagram, and we have seen what all lines are present in the Molier chart. Now let's move to our next point, that is what is the concept of or how to use the steam table in the next slide. In this slide we will see what is the concept of steam table and how to use this steam table. This table is very important for solving the numericals. I will show the steam table, that is how actually it looks like in the further slides. But before going for the actual steam table, we should know what are the contents of this steam table. So you can see here there are two types of steam table. So one is the pressure basis steam table, and the other one is temperature basis steam table. And if we look at the contents of this table, then for either for pressure based steam table or for temperature based steam table, the contents are not different. Thus in the steam table we are having the different properties of steam, such as the saturation temperature, saturation pressure, then again we are having specific volume, specific enthalpy, and specific entropy. In the given steam table, if we are having the absolute pressure in bar as the first column, then we call it as the pressure basis steam table, whereas if we are having the first column as the temperature, then we call it as temperature basis steam table. So in this slide you can see how the pressure basis as well as temperature basis steam table is given. We can also observe some notations that are given in this table, such as P, it is nothing but the absolute pressure of steam in bar. Then again we are having T saturation, that is saturation temperature in degree Celsius. Again, we are having, in case of specific volume, we can see two columns. One is water, whereas the other is for steam. So the notation VF, it stands for a specific volume of saturated vapor, and its unit is meter cube per kg. Whereas the VG, it is nothing but specific volume of dry saturated steam in meter cube per kg. Then the next column is for specific enthalpy. In case of specific enthalpy, we are having again three sub columns where we can see water, evaporation, and steam. So HF, it stands for enthalpy of saturated water. HFG, it is the enthalpy of evaporation of steam, or we call it as latent heat of evaporation. And the last one, that is HG, it is the enthalpy of dry saturated steam, and the unit of enthalpy we are having as kilojoule per kg. And the last column, which is the next property of steam, that is specific entropy, and again we are having three sub columns in that. So SF, it is nothing but the entropy of saturated vapor. SFG is the entropy of evaporation, and finally SG, it is the entropy of saturated steam with unit as kilojoule per kg Kelvin. So now let's see how the actual pressure basis or the temperature basis steam table looks alike. So this is the pressure basis steam table. As I mentioned earlier, if we are having the first column as pressure, we call it as a pressure based steam table. So you can see that for various values of pressure, we can observe the values that are given for specific volume or temperature, specific enthalpy, or specific entropy. So all these values are determined experimentally, and these are tabulated in this table, and we call this as a steam table. It is also important to note that while calculating this experimental data, water is taken as a reference at 0 degrees Celsius. So this was related to the pressure based steam table, and similarly we can also look at the temperature based steam table. So in this case, again all the remaining part is same, just the difference will be here. We will be having the first column as the temperature, and the second column will be for pressure. So this was all about the use or the concept of steam table. Okay, that's all for today, and I think that you now have understood what is the steam table and how to use this steam table. But we will see more regarding the use of this steam table when we are solving the numericals. So for now we will stop here today. Thank you very much.